This is a carburetor, and its job is to mix fuel and air together and deliver them to an engine. I've cut this one in half to show you how it works. In case you didn't know or don't know, unlike electronic fuel injection, a carburetor relies entirely on just varying air pressure and a couple of mechanical parts to get the job done. There are loads of variations on design, but every carb works on exactly the same principles, and they all have at least three things in common. They all have some sort of float chamber, sometimes known as a bowl. That's this part here, and it's where the fuel lives. They all have, obviously, an area like this, which is where the air flows. In this case, it comes in this side and goes out this side. And they all have a version of this little brass pipe that goes between the air feed and the bowl. The air feed will always have a similar profile to this, and it's the main reason I've cut this carb open. I wanted to show you a cross section so we can take a close look at the profile of the airflow. Now, you'd be forgiven for thinking that we'd want this profile to be arrow straight so the air can fly through undisturbed, avoid turbulence and uneven flow and other things that we hear people complain about when they're trying to get 1,000 horsepower out of a Honda Civic. But actually in a carb, the last thing that we want is linear airflow. If we look closely at this profile, you can see it starts off quite big and then rapidly reduces in diameter. Every carb that has existed or will exist will have some sort of variation of this profile in it. There's a name for it. It's called a Venturi nozzle, and it's where the magic happens. Now, the Venturi effect is when air is flowing through a certain area, then you rapidly reduce the available space. The air has to keep moving, and the only way it can all fit through a smaller gap is by traveling at very high speed. When air travels at high speed, it creates low pressure. I've got a good demonstration for this. It involves a funnel, some compressed air, and a ball. Now, if I put this ball in the bottom of the funnel, I put the compressed air in the bottom and blow, common sense tells us this ball is going to shoot out the top. But it doesn't. It's actually the opposite that's happening here. In fact, if I do that again and turn this whole thing upside down, the ball somehow defies gravity and it just hovers there. Aside from being a nice party trick, that neatly demonstrates the Venturi effect in action. Because when the ball is at the bottom of the funnel or the top when it's turned upside down, and I force air through here, it has to squeeze around the ball. And it's such a tight space between the funnel and the ball that the only way for the air to get through there is to travel really fast. The air is moving so quickly in that tiny space, the ball is able to hover there, and it's not witchcraft, it's just because the atmospheric pressure underneath the ball is higher than the pressure above the ball, so in effect, it's being pushed up. That's how our carb works. If I go back to our cross section and we look at this profile, just like the ball in our funnel, this area right here forces the air to travel really fast, specifically right here. And it's also where our spray nozzle is. And that means the air pressure at the top of the nozzle is lower than the pressure at the bottom of the nozzle where the fuel is. So the fuel moves from the bottom to the top and mixes with the air. There you go. Now you know how a carb works. If you'd like me to go through other parts of the carb and how they work in more detail, let me know in the comments. Or if you want to understand how other parts of an engine work, I'll try my best to explain them.